Hi, in the previous video, I have started the Light Scheduler in the IDE and walked through the APIs. In the current video, I'm gonna start the Light Scheduler in the cluster mode so that we can demo the high availability as well as the fault tolerance features for the Light Scheduler. When we start in the cluster mode in local with Docker Compose, we have to start Confluent Platform with Docker Compose because in our Docker Compose for the Light Scheduler, we are using the service name from a Confluence platform in the Docker Compose. So first, we need to go to the network NT Kafka sidecar folder and start the Docker Compose here with the Confluence platform. Once we have a Confluence platform started, we need to go to the control center to create two topics for the Light Scheduler. Now let's move in this window so that we can access the controller. The controller URL will be localhost 9021. And let's go to the cluster and go to the topic. So you can see here we don't have any extra topics. We need to create two topics for the Light Scheduler. Add topic. The first one we want to add is the Light Scheduler. And since we start 3-node cluster, we're going to use 3 partitions. Light Scheduler. Create this default. And let's create another topic. We call it controller health check. Also, we want to create 3 partitions for this topic. So now we have 2 topics created already. Let's move this away. And let's start the Light Scheduler. In the Light Scheduler folder, we have Docker Compose here. So we can just use the Docker Compose. Docker Compose up. The Docker Compose up will start 3 nodes. Now you can see we have a node 1 with the A8401, node 2 A402, and node 3 A403. The 3 nodes are up running. You can check the Docker Compose file there, see how the configuration is done. Now let's start some testing. Let's move in another terminal so that we can issue some command. So let's first query on the server. Let's say this is we are querying the server node 3 because we are using A403. But if you want to change, we can change this to A402. And you can see we got the exactly same result, A401. We got same result, it's empty. This is the empty response here. So let's create a new task definition through node 1. We have this command here already cached, so that we can use this one. You can see we have curl-k and using A401 with the content. This is the raw data, which create every 10 seconds. Insert task definition is pushed into the controller health check topic. This is the detail for the health check. So we're going to run this command. Yeah, this is done. And now you can see we have this information say punctuate trigger task key. This is coming from node 1. So basically we send a request to node 1. So node 1 create this task definition and schedules and start scheduling tasks using this node. You can see seconds. This is trigger task. Every 10 seconds you will see this this log in the console. Let's wait for another 10 seconds. We'll see another entry here. So see here, there's a new entry here. So that meaning is working for the task scheduling, and it's done by the node 1. Now let's go back to node 1 to do the query. You can see we got a result come back. This is one scheduled task. And if we say we are not querying node 1, we query node 2, you got exactly the same result. Node 3, you will have the same result. So basically, like every last scheduler node you do the access through API, you will get exactly the same result, although the task creation was done on node 1. So let's stop the node 1 and see what happens. So we're going to run this in the same folder with another terminal. Say right now, we are in the light scheduler folder. We're going to run this command to stop the node 1, scheduler node 1, which is the service name in the Docker Compose. So let's run this, stop. You see, right now we are still trying to we're still reproducing from node 1 for the task execution. Now you see we have node 1 exists with code 137. So at this moment, like we have, you see the message come back from a Kafka stream. The stream basically is rebalancing between node 2 and node 3. And now you see from node 2, we are trying to schedule trigger the task. See that this is done for every 10 seconds. So you have another one. So basically this means after the node 1 is stopped, the node 2 takes over the partition from node 1 and trying to schedule the task like distributedly without stopping like the task running. Now let's say we restart node 1. Let's see what's happening. Let's run the Docker Compose start scheduler node 1. Run this command. This will start node 1. So you can see once node 1 started, it's immediately trigger the Kafka stream rebalancing. And you can see here, we are sending the task from node 1 again. So this is the first one from node 1. This is second from node 1. So at this moment, every 10 seconds, the node 1 will create a task and push into the controller health check so that the controller can continue doing the health check like for the registered services. So this meaning once we have a node 1 restarted, the Kafka stream rebalanced again, then the task scheduling like basically taken back by the node 1. So this proves like even though we can stop and restart a node in a cluster, the entire operation is not stopping, and this is fully distributed and is high available, unless we stop all these server instances altogether. Once this is deployed to the Kubernetes cluster, if you have rolling deployment, then your service won't be stopped. Every time you deploy a new service, you stop a new service, you deploy the new service, all the load balancing will be done like between different existing nodes. Yeah, that's it. Thank you. Bye-bye.